Right, let's start calculating straight away. Set 14. Set 14. Okay, so this is just a lot of noise. So we'll make an exception for this one. Which of 7.09, 6.918, 7.17, 6.77, 7.085 is closest to 7? First one is 0.09. Second one is 0.082. Second one is winner so far. Winner so far. 6.918. How many integers are strictly between 20 plus 18 and 20 times 18? 20 plus 18 is 38. 20 times 18 is 360. Now, 38 is the lower bound. 360 is the upper bound. But what do we do? What do we do? How many integers are strictly between 10 and 12? The answer is 1. What you do is upper bound minus lower bound minus 1. So 360 minus 38 minus 1. So 321. 321. You ask us how many integers are strictly between 20 plus 18 and 20 times 18, and we say 321. How many three-digit numbers have an odd number of factors? Those numbers with an odd number of factors are precisely the square numbers. Square numbers. The lowest three-digit square is 100. The greatest three-digit square is 961. 100 is 10 squared. 961 is 31 squared. So, how many is that? 10, 11, 12, all the way up to 31. What you do is upper bound minus lower bound plus 1. So 31 minus 10 plus 1, which is 22. 22. You ask us how many three-digit numbers have an odd number of factors, and we say 22. Which is 17 over 6, 18 over 7, 19 over 8, 20 over 9, and 21 over 10 is closest to 2. Is that right? Yeah, that's right. Which is 17 over 6, 18 over 7, 19 over 8, 20 over 9, and 21 over 10 is closest to 2. Okay. Now, it's tempting to say the very first one, because the sequence is obviously tending to 1. However, let's just be careful now. 17/6 is nearly 3, as you can see. 17/6 is 2 and 2, 6, 2 and 5, 6. 2 and 5/6. 18/7 is 2 and 4/7. 2 and 4/7. (19/8). 2 and 3/8. 20/9. In fact, I just realized here that this ends in 21/10, which is 2.1. That's closest. That's closest. You ask me, what is closest to 2? 17/6, 18/7, 19/8, 20/9, or 21/10, and I say 21/10. Which of 202 divided by 6, 202.6, 20 plus 26, 202 minus 6, or 20 times 26 is the smallest? It's certainly not 20 times 26, which is 520. (202 divided by 6 is 35-ish, 35-ish, 35 and a third. No, do it correct. 202 divided by 6 is 33 and a third. 33 and 2/3. 33 and 2/3. Smallest thus far. Plus 26, 46. It's 202 divided by 6. 202 divided by 6. You ask us which of the following is the smallest, and you say 202 divided by 6, 202.6, 20 plus 26, 202 minus 6, 20 times 26, And we say 202 divided by 6. Yeah, that's fine. That's fine. Okay, a lot of noise in this one. There are 5 entries, all right. Which of 20 plus 22, 202 plus 2, 202 times 2, 2 times 0 times 2 times 2, and 20 plus 22 is the largest, right? No, try again. All right. Which of 20 plus 22, 202 plus 2, 202 times 2, 2 times 0 times 2 times 2, and 20 times 22 is the largest? Which of those is the largest? First one is 42. Second one is 204. Third one is 404. Fourth one is 0. Fifth one is 440. So it's the fifth one. 20 times 22. You ask us which of the following is the largest. 20 plus 22, 202 plus 2, 202 times 2, 2 times 0 times 2 times 2, or 20 times 22, and we say the last one, 20 times 22. How many of the following are multiples of 11? 187, 156, 253, 495, 132. Right? Yeah, that's right. How many of the following are multiples of 11? 187, 186, 253, 495, and 132. The first one is 11 times 17. The second one is not a multiple of 11 because the closest multiple of 11 is 154. The third one is 23 times 11. The fourth one is 45 times 11, and the last one is 11 times 12. So 4 out of 5 of them are multiples of 11. You ask us which of the following are multiples of 11. 187, 156, 253, 495, and 132, and we say 4 of them. How many digits are in the result of 123 billion, 123 million, 123,000, 123 divided by 123? The result of that will be 1 billion, 1 million, 1,001. And that will have 4 ones, each with 2 zeros between them. And thus 4 ones and 6 zeros, which makes 10 digits. 10 digits. So you ask us, how many digits are in the result of 123 billion, 123 million, 123,000, 123 divided by 123, and we say 10. Okay. How many 3-digit numbers equal 34 times their digit sum? All right. 34 times their digit sum. Okay, so how are you going to do this? Okay. $34. All right. So, 102 is an example because the digit sum of that is 3. And 3 times 34 is 102. Where are all... 34 times 3 is 102. That's the lowest example. Thirty-four times 34 times 29 is the highest example. So 3 and 29. All right, the bus noise is very loud. 34 times 29. Yeah, so what does that mean? That means that there are 27 examples to look through, and we've already covered one of them. So well, just continue on until you spot something. 102 definitely works. 136. 136 does not. 170 does not. Wait a minute. 8 times 34. No, that doesn't work. 204. 204 does work, because the digits add up to 6, and 6 times 34 is 204. So those two work. $238. $238 does not work. $272. That does not work. 306. That does work. The third one worked, and the sixth one worked, and the ninth one worked. And so we think that the 12th one will work as well. Twelve times 34 is 408. Whose digits add up to 12. That does work. It's the 3 times table. And let's see now. 29. 3, 6, 9, 12, 15, 18, 21, 24, 27. So 9 of them. Is it 9 of them? Is it 9 of them? Check the last one. At the very least, check the last one. 34 times 27. That's 102 times 9, which is 918. 918, the digits add up to 18. And 18 does not work. Try and think about what the number looks like. Come on. $100A plus $10B plus C is equal to 34 times A plus B plus C, right? So 34A, 34B, 34C. Does that actually help you or not? I do not think so. 66A minus 24B minus 33C. All right, so it's obvious now that they have to be a multiple of 3. All right, you get it now. Okay. So that narrows down the set to just 9 of them. The first 3 work. So now do the 4th. Now do the 12th one. Yeah? Do 12 times 34. Okay, that's 408. Whose digits sum to 12, which works. 15 times 34, that's 510. Whose digits sum to 6, which does... Is that right? Yes, that's right. Whose digits sum to 6, which does not work. 18 times 34. 18 times 34. Come on, 18 times 34. Well, that's 68 times 9, which is 612, which does not work. 21 does that work? 21 times 34, 714. Whose digits sum to 12, which does not work. 24 does not work either. 24 times 34 is 816. Whose digits sum to 15, which does not work. And 27 does not work, as we've established. So it's only 4. It's only 4 of them. Okay. How many 2-digit numbers have 1 digit twice the other? Right? Yeah. How many 2-digit numbers have 1 digit twice the other? Okay. 21 and its reverse. 42 and its reverse. 63 and its reverse. 21, 42, 63, 84. And that's it. 21, 42, 63, 84. And so therefore there are 8. You ask us how many 2-digit numbers have 1 digit twice the other, and we say 8. All right. All correct. Excellent. Excellent. Alright, set 15 now. Set 15. A cube has volume v cubic centimeters and surface area 2v square centimeters. Find v. All right. So when is the volume of a cube? Twice its surface area. That's what you're asking. So letting the side lengths of a cube be x, the volume of a cube is x cubed. The surface area is 6x squared. And in this case, we're not asking when is x cubed equal to 6x squared, but rather when is x cubed equal to, or rather, no, hold on just a minute now. We are not asking when does 6x squared equal x cubed, but rather when does 2 lots of 6x squared equal x cubed. In other words, 12x squared equals x cubed. So 12 equals x. 12 equals x. That's the side length. As for the value of v itself, it's 1728. Because, wait, that cannot be right. If v is 1728, then I'm saying that the surface area would be half what it should be. So we actually got it the other way around. So 2x cubed should be 6x squared. So x cubed should be 3x squared. So 3 should be x. Yeah, that makes sense. Then the volume would be 27. And the surface area, or rather 2v, would be 54, which actually is the surface area. So v is 27. Not sure why I stumbled there, but there you go. Okay. Oh, wait, I forgot to say it. You ask us if the volume of a cube is v cubic centimeters and the surface area of a cube is 2v square centimeters, find the value of v, and we say 27. V is 27. Okay, now you ask 2 squared times 3 cubed times 5 to the 5 times 7 to the 7 when divided by 8 leaves a remainder of what? All right, then. Now, what do we need to know to determine this? Well, if we're dividing this quantity by 8, We should know the last 3 digits technically, right? But how to go beyond that? Like, what is the technique? How does it go again? That leaves a remainder of 3. $108. That leaves a remainder of 2. So how is that working? What's the actual technique then? Eleven has a remainder of 3. 13 has a remainder of 5. And their product has a remainder of 7. Three times 5 is a remainder of 7. Isn't that what you do? You find the remainder for each of them individually, and then you multiply them and then look for the remainder there, right? Alright, then with 2 squared it would be 4. For 3 cubed it would be 3. For 5 to the 5, that's 3,125. It would be 5. So 435, 435 And for 7 to the 7, it alternates 7 1 7 1 7 1 7. So it would be 4 3 4 3 5 7. And their product is 420. And their remainder is 4. So it would be 4. You ask us, what is 2 squared times 3 cubed times 5 to the 5 times 7 to the 7? When divided by 8, what is its remainder? And we say 4. This is funny. Which of zero 0.87, 0.88, 0.95, 0.96, 0.98 is equal to 0.8 recurring plus 0.0 recurring 7. Yeah. Which of, come on, which of 0.87, 0.88, 0.95, 0.96, 0.98 is equal to 0. Recurring 8 plus 0.0 recurring 7? 0. Recurring 8. That would be 8 over 9. 0.0 recurring 7. That would be 7 over 90. 8 over 9 plus 7 over 90 is 80 over 90 plus 7 over 90, which is 87 over 90, which is 0.87. That's the very first option that you gave. You ask us which of the following 0.87, 0.88, 0.95, 0.96, 0.98 is closest to 0. Recurring 8 plus 0.0 recurring 7. We say 0.87. What number has a quarter that is 9 more than the whole? So you're saying X over 4 is equal to x take 9. Or rather, x over 4 is equal to x plus 9. So negative 3 over 4x is equal to 9. So negative x is equal to 9 times 4/3. So negative x is equal to 12, so x is equal to negative 12. You ask us what number has a quarter that is 9 more than the whole, and we say negative 12. What day of the week is 2023, oh rather, what day of the week is 2023 days after Thursday the 16th of March 2023? You did not ask us for the date, so we need only calculate the day. The closest multiple to 7, multiple of 7 to 2023 is let's see now. Well, there's 2,100, but that's way up there. 2030, that's better. (2023) actually is a multiple of 7. So 289th. So it's a Thursday. Which of 765, 675, 585, 495, and 305 is not a multiple of 45? Now, 45 is 9 times 5, and they're all multiples of 5. And thus we need only check that they are multiples of 9. 765 is not. No, it is. It is a multiple of 9, so it passes. 675 just permutes the digits, so it also passes. 585 passes as its digital root, as its digital sum is 18. 495 passes as those add up to 18, but 305 does not. And since you asked me which is not a multiple of 45, and I've accidentally been checking for multiplicity of 45, we say 305. So you asked us which of the following is not a multiple of 45, and you said 765, 675, 585, 495, and 305, and we say 305. Five consecutive integers sum to 2015. Find the smallest of them. If they are consecutive, then they have the form x, x at 1, x at 2, x at 3, x at 4. And we sum those and we get 5x at 10. So 5x at 10 is equal to 2015. So 5x is equal to, did you say 2015? You did. All right, we have to begin again. 5 consecutive integers sum to 2015. Find the smallest of them. Okay, because they're 5 consecutive integers, they have the form x, x at 1, x at 2, x at 3, x at 4. When we add those together, we get 5x at 10 equals 2015, and thus 5x is equal to 2005, and thus x is equal to 2005 divided by 5, which is 401. 401. And since x stands for the least of those integers, it is 401. So you say to us that 5 consecutive integers sum to 2015 and ask us to find the least of them, and we say 401. How many pairs of 2-digit positive integers differ by 50? How many pairs of 2-digit positive integers differ by 50? All right, they should range from 10 and 60, 10 and 60, all the way up to 49 and 99. Count the integers from 10 to 49. You need to do 49 minus 10 and then plus 1, so we get 40. Now, it's not clear if they are order sensitive here, so it's either 40 or 80 depending on how you count. But you ask us, how many pairs of 2-digit positive integers differ by exactly 50? And we say 40 or 80 depending on how you count. Okay. 2w at y is equal to £5. 3w at 2y is equal to £10.50. 2y at 3r is equal to £11. Find r plus w plus y. Let's try that again. £2w plus y is equal to £5. 2w plus 3r is equal to £10.50. 3y plus 2r is equal to £11. So find r plus y, r plus w plus y. Okay. It would benefit us to find the sum, to find all of these individually. I'd require solving this matrix. Okay, so y minus, no, we should do it the other way around. All right, fine. So 3r minus y is equal to £5.50. 3r minus y is equal to £5.50. Y is equal to r plus £5.50 then? No. Y is equal to r minus £5.50. Thank you very much. So 2r minus £11. 5r minus £11. 5r minus £11. So 5r is equal to £22. No, it's very, very hard to keep in my head. Okay, so you say 2w plus y is equal to £5. 2w plus 3r is equal to £10.50. And 3y plus 2r is equal to £11. So find r plus w plus y. We do the second equation minus the first equation. So on the left we have three r minus y. 3r minus y is equal to £5.50. So y is equal to 3r minus £5.50. Y is equal to 3r minus, oh goodness me, 2w plus y. 2w plus y is equal to £5. 2w plus 3r is equal to £10.50. 3y plus 2r is equal to £11. Find r plus w plus y. Second equation minus the first equation. It's 2w plus 3y. So the 2w from the second and the first cancel out. And on the left we have 3r minus y. 3r minus y is equal to £5.50. Y is equal to 3r minus 5.5. Y is equal to 3r minus 5.5. Nine r minus 16.5. 11r minus 16.5. 11r is equal to 27.5. R is equal to £2.50. R is equal to £2.50. Now we use the second equation. £2w plus 3r equals £11. No, 2w plus 3r is equal to £10.50. So we're going to do 3 times £2.50, so we get £7.50. Take that away from £10.50 and we get £3. And 2w is equal to £3, so w is equal to £1.50. Now we just need y. using the first equation, 2w plus y is equal to 5 pounds. So 3 pounds plus y is equal to 5 pounds. So y is equal to 2 pounds. Y is equal to 2 pounds. So R is £2.50, Y is £2, W is £1.50, and altogether £5. It's £5. We believe it's £5. Okay. So what you said to us was, I think that's enough for that question. Next one. Which of the following 0.1, 1, 10, 100, 1000 is closest to 2.015 times 510.2? Now, we know that it's 1000. So you ask us which of the following which of the following 0.1, 1, 10, 100, 1000 is closest to 2.015 times 510.2, and we say 1000. You know what I'm actually concerned about is but 8 over 9 is 0 point recurring 8. And 0.0 recurring 7 is 7 over 90. 8 over 9 plus 7 over 90 is 80 plus 7 over 90. 87 over 90. 87 over 90. Oh, darn it. You fell for their trick. Goodness me. Running on autopilot, I thought the denominator was 100. 87 over 90 is 29 over 30. Eighty-seven over 90 is 29 over 30. Yeah, 0.96 is closest, but it's not exactly equal to. Not concerned with that one. It's just... Although I want to do more